Calculating the mass using a volume of a gas by KayScience.com. Here is a typical exam style question asking you to calculate the mass of a reactant needed to produce a certain volume of a gas. The question says, lithium reacts with water to form lithium hydroxide and hydrogen. Calculate the minimum mass of lithium needed to produce 144 decimeters cubed of hydrogen at room temperature and pressure. And here is the balanced symbol equation. The question is asking us to calculate the minimum mass of lithium, so we write mass under Li with a question mark to remind us this is what we're trying to calculate. And we're actually trying to calculate the minimum mass of lithium needed to produce 144 decimeters cubed of hydrogen. So we write volume under hydrogen and 144 decimeters cubed, as this is the volume that we are given. To calculate the mass of lithium, we need to know the AR, relative atomic mass, and moles. From the periodic table, we know the AR of lithium is 7, and we do not know the moles, so we write a question mark, as this is what we need to calculate as well. We can calculate the moles of lithium if we know the moles of hydrogen. To calculate the moles of hydrogen, we use molar volume, which we write here, which is 24 decimeters cubed, and then we write moles here, as this is what we're about to calculate. This is the formula triangle you need to remember for this equation, where moles equals volume divided by molar volume. Because we're given a volume of 144 decimeters cubed and we're using a molar volume of 24 decimeters cubed, we do not need to convert the units. Using the equation, moles equals 144 decimeters cubed divided by 24 decimeters cubed, which equals 6 mole. So here we write 6 mole. Using the equation, we can see the ratio of moles is 1 mole of hydrogen to 2 moles of lithium. So when calculating the moles of lithium, we have to multiply the 6 moles by 2. So 6 mole times 2 equals 12 mole. To calculate mass, we use this formula triangle, where mass equals AR times moles. So we do 7 times 12 mole, which equals 84 grams. 84 grams is the minimum mass of lithium needed in this reaction. It's question time. Attempt these questions to check your understanding. Pause the video now to attempt this question. The answers will follow. Pause the video to check your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. If stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.